Good afternoon. Welcome to our new webinar. My name is Fabrice Brimioulle. I'm an IT consultant of ATIX, and today I'm going to tell you how to simplify deployment of virtual machines in the best way. So, why should we simplify and automate deployment of virtual machines? So, first of all, if you have to set up many machines, this is a quite repetitive task. It's quite boring. It takes time. So basically, first of all, automation speeds up your deployment. These are many, many steps which have to be done. And by automizing, you can all write them down. And when it is to be repeated, you can ensure that everything is done the same way. So you wouldn't like to have a server which differs by the name by one letter or by one configuration from the other because you just created a typo. So besides speeding up, you create stability and reproducibility, and you can fully orchestrate your service. So you can configure all the services which are to be installed and all the packages which are to be running on your machine. And last but not least, you also enable self-service. So suppose you have developers who are working on their virtual machines and they're testing, and then something breaks and they have to be redeployed. Instead of writing a ticket and having to wait hours or days until the service has to be rebuilt, you can just create a self-service and tell them how to rebuild the servers themselves and just get everything running. So basically, configuring everything with orcharhino, you can deploy a virtual machine with just 3 clicks when you have everything pre-configured. So we support deployment on many, many platforms. So basically virtual machines on VMware, overt, KVM, libvirt, and so on. But we also support deployment in the cloud with the Azure, Microsoft Azure, with the Amazon Web Services and the Google Cloud Platform. So when you are deploying a machine, one important part of that is configuration management. So you can do that independently. The 3 most famous tools which are supported by us are Puppet, Ansible, and SaltStack, which follow slightly different philosophies. Puppet is a server client system, so it means there is a Puppet master, where the configuration for all your servers are stored. And on the clients, there is a Puppet agent running, which regularly asks on the Puppet master what the configurations are to be. So the agent then normally every 30 minutes checks on the master. If the configuration differs, it will be corrected so it matches. If it's different, if it's the same, Puppet is happy and everything stays like it is. Ansible is different from the approach. It's more or less a fire and forget. So with Ansible, you push your configuration to the service via SSH connection, rather than using an agent where the configuration is pulled. The third tool is SaltStack, which is a hybrid between both. So you can use SaltStack as a master client system as well. In this case, you have a Salt master, where all the states are stored. And on the clients, there is a Salt minion running, which regularly checks and configures the host according to the configuration stored on the master. But you can also pull all your push all your configurations from the master to the clients via SSH. A further important step in the life of the server is the patch management. So basically, these are, for example, errata. So errata are basically something like a prescription. So for medicine, so it tells you what packages are affected by a CVE, by a bug fix, or by an enhancement. Originally, errata were only available for enterprise systems like Red Hat, Oracle, or SLES. We also created errata from the security issues on Debian and Ubuntu, where originally this concept didn't even exist. Close to that is the release management. So most companies have several life cycles where the server run. For example, development service, testing service, and production service. In order to write that, we can store repositories on orcharhino. So it means we can just synchronize them and use them as local repositories and connect our servers there. These repositories we can freeze to a defined state. So if I have to deploy a server 1 week, 1 month, or 1 year from now, with exactly the package states like they have been today, I can publish a so-called content view and then provide the package states like they have been today also in the future. This allows us to do this release management. So in general, development has the latest state, testing is slightly older, production is the most conservative and is sort of the older state. So if I have now my content view and all the packages have been developed by developers, and they say everything is fine, it's stable enough, it can be tested, I can just take my content view version and promote it as a whole to testing. Once I've done that, all the test servers will see exactly what the development servers have been seeing before. This way, we can avoid dependency errors or anything else which happens if we only promote a certain subset of packages to the current lifecycle. The same happens when the testers say everything is fine, it's stable, it can be rolled out for production. Then we just take our content view version, we promote it to production, and then production servers will see exactly what the testing servers have been seeing before. Also very important in this context is if we have to use a bug fix. So suppose we have figured out there's a security issue which has to be fixed. And the fix is not yet part of the lifecycle, of the content view lifecycle we are using right now. We can just do a so-called incremental update. So we can create a new content view version based on the old one, where only the packages which are required to fix the issue are pulled into the content view. This way we can avoid to have to prematurely promote unstable content views to servers before they have been tested, and nevertheless fix issues which are open. So basically, with orcharhino, we are able to map the whole lifecycle of a server. So this starts with with deployment. So the server is being built in the cloud as VM, also as bare metal server. We run our configuration management, so we can configure all the packages and all the servers which are to be run with Ansible, Puppet, or SaltStack. And in the end, we can also do release management, so we can update our packages with a general overview of the versions which are installed. And we can also patch our service with a certain errata which have been provided. So basically, all of this defines the package of orcharhino. As said, we support every Linux operating system and also configuration management deployment of Windows servers. With a consulting department, basically, which is there to install orcharhino. So if a customer orders orcharhino, the consultant goes there and installs the software and checks out which plugins are the most favorable in this context and how infrastructure has to be built. Out of the consulting, we also provide the orcharhino training. So every customer who has ordered orcharhino is able to order a training to learn how to use orcharhino to get the best usage of it. As said, we support deployment on VMware, KVM, Proxmox, and also in the cloud. Being an enterprise solution, we also provide support. There are several solutions for support. The most basic one is just ticket-based. So if there's a problem, customers can open a ticket. The support will have a look at it and help to fix the issue. There are also more sophisticated models which go so far that we are even able to run orcharhino and the whole infrastructure if requested. Engineering is there to basically release and to build new orcharhino versions. So orcharhino is based on the upstream project Forman and Cartello. So basically, from this upstream project, we backport fixes. We develop also several plugins. For example, the snapshot plugin has been developed by us that allows on Proxmox and on VMware to snapshot machines directly without having to go to the compute resource itself. We also developed the SCC manager, so this is a plugin which allows to synchronize SUSE repositories on orcharhino and to provide it to SUSE servers directly. So basically all of this defines orcharhino, and if you order that, they will obtain all of these features. So if you want to have a general overview in favor of that, the documentation webpage is here on docs.orcharhino.com. Basically here you can see all the features and documentation and see how everything works. So if you have any questions, you can write them out in the chat. I will have a look in it and will address them then. In the meanwhile, I will start and switch to the live demo. So I will switch to our orcharhino demo ATIX and show you how orcharhino is run in practice. Okay. Now here you can see the host page of our demo orcharhino. So you see here many servers. You see that we support many operating systems, starting with Alma Linux, CentOS 7, CentOS 8, Debian, Oracle Linux, Red Hat, Rocky, SUSE, Ubuntu, but also Windows servers. So let's just start to show you how simple it can be to deploy a virtual machine. For this, we just click on Create Host. We will get here a certain form, so we have to give a name. So let's deploy a webinar Ubuntu 20, for example. That was one name. Now we have a so-called host group. In the host group, we can predefine every parameters which are to be run or used for our virtual machine. So basically, this is the first step of automation. So let's have a look for our Ubuntu 20. We choose that, and you will see that everything has been pre-filled. I will address the different parameters a bit later. Now this was to illustrate how simple it is to submit into a virtual machine. So we click now on submit. That was the third click. And we see the machine is being created. So this is now the host page, which shows all the different parameters for our virtual machine. So you see, we can already see the first different parameters. Not too much because the machine is being built yet, but we see the status is still okay. We see it's an impending installation. We see the domain, the IP address. We see that the salt master has been defined, the salt environment, where our machine is running, MAC address, puppet environment, architecture, and much more. But let's have a look at a machine which already has been built to show you what we can do with it. So we had prepared this machine here before. So we see our general status. The general status of this machine is error. Why is that? So the status here is just a summary of all the different parameters which are below. So we already see here that this issue comes from the errata. So for this service, the server, there are security errata available. So we can have a look how to apply patches on a server. And we see here basically all the different parameters are the same as before. So let's have a look how we do that. So for that, we go here and we click on content. So we see here everything which has to do with the content management and packages and much more of the server. We see here the content view which has been assigned. So it's a Ubuntu 20.04. This is a frozen package state we have assigned to the server. And we see here, this is a test server living in the testing lifecycle. In the subscriptions here, we can see what products have been assigned to our server. So basically we have a Ubuntu client, which is there to communicate with orcharhino. We have Ubuntu itself, we have Puppet, and we have SaltStack. If we go here to the last tab on repository set, we actually see what repositories are available to the server. So, but as we saw, but we have errata available. Let's have a look at the errata. So now we wait a few seconds until everything has been loaded. So you see here we have in total 79 open issues which can be applied. So let's have a look on one of the errata. So we see here, for example, the Linux kernel vulnerabilities. So if we look in here, we see here the description. So what the issue is about, we see when it has been issued, and we see the pseudo resolution. So these are the packages and the versions to which they have to be upgraded to close the issue. So let's go back and apply this erratum. So now we have to wait again until the page has reloaded. So to apply an erratum, you just click the checkbox and you click on Apply Selected. By this now, a remote execution will be triggered on the host. So an SSH connection will be opened from orcharhino to the host. And if we click here on Preview Template, actually, we see here, this is the script which is going to be run on the server. So we can scroll now here down and also click on the server name. Then we will see on the shell of the server what actually is happening. And we see here now the action which is running on the shell, and we see that the packages are being installed or upgraded. So let's wait a second until everything is run through. Taking a bit longer than I hoped, but never mind. Let's get back to this job a bit later. So let's get back to our host. So we were running on this host here. So now let's just explain what we are able to configure. So if we click here on Edit, we see basically what was set in the host group before, and we see everything which can be defined. So we see here the host group, which defined all the default values. Here we define where the host is going to be built. So in this case, we are deploying it on our vCenter. We define the lifecycle and the content view where the host is put into. The content source, so basically this is the server the host subscribes to and where the repositories are stored. We have here our Puppet environment. The server is set in the Puppet proxy, which in this case is orcharhino. This is quite standard, but it's not mandatory. It's also possible to use an external Puppet master and connect it to orcharhino and just forward Puppet reports and facts. And further to that, we also can assign an OpenSCAP proxy in order to assign policies to our server and check if it fails certain policies which have been defined. And the last part down here is this part for SaltStack. So in this case, we have defined orcharhino to be the salt master and assigned it to the salt environment base. So further to that, here we can now assign the salt state. So we see here the message of the day has been assigned with SaltStack, as well as with Ansible. So basically, it does not really make sense to assign with two tools message a day, but in illustration, things make sense because in this way we can just see how SaltStack and Ansible override each other and how things change. Here we can prefine our virtual machine. So when deploying a machine, we can just define a basic t-shirt size, we like to call it, where we define the standard number of CPUs, memory, and the hard disk size, but this also can be overwritten. Here in the operating system, we define the architecture, the operating system which is to be installed, the installation medium from which it is installed, the partition table, and the Pixie loader. Here we can define the network configuration for our servers. Here we can assign Puppet classes as well, and additional parameters. So basically, we can now have a look on it. No, it's reloading. Let's wait a second until it's reloaded. We can basically have a look here. Now we see our job from before has run through. We see here the job has been a success. If you go back, we see that the kernel erratum is no longer shown because it's no longer open. And in addition, if we look here at traces, we see that the kernel update requires the server to reboot it. So you see here, kernel, and we'll have to reboot your server. And if we look back on our host page, we see an additional error message and traces that a reboot is required. This is not done automatically because the administrator himself has to decide when to reboot a machine. So this has to be done manually when you're sure this can be done safely. So now we can have a look on how to send remote execution jobs manually. So if you click here on schedule remote job, you will see here many different options. You can send just a normal command on your server, for example, not an update, but an uptime. So we see this was successful. If we click on the shell, we get a response here. You also can run Ansible commands. You can switch off and on your server. You can trigger Puppet and SaltStack. So let's do an example here. So we can here on the right button, for example, we can run our Ansible roles, SaltStack or Puppet. So let's just run our Ansible roles once more. So we look on preview templates, and basically that's the task which is being run. We can have a look on our shell, and we see that the role is being rolled out right now. We see something has changed, and the task will be done in a few seconds. So it's done. Everything worked fine. We go back to our host page, and now let's have a look on the report. So here you see we have here the button reports, where every configuration manager run reports back what has happened. So we see here we have Puppet runs which ran through. So let's have a look at one report. So we see here that Crony has been configured, for example, on this host. We see here the first Ansible run, which ran about 1 hour ago, where the message of the day has been set. Here we have our SaltStack run, which overrode what Ansible has done. And just now, our latest report shows us how the message of the day has been reset by Ansible. So now let's have a look on the content management, which is very important when deploying a server. So if we have a look here now on content, we have so-called products which cluster related repositories. For example, a certain product like Puppet, or also the repositories for an operating system. So in our case, let's have a look at Ubuntu, because we started with that. Ubuntu is on the second page. So let's look at Ubuntu 2004. So here basically we have here now 3 repositories: focal main restricted, focal security main restricted, and focal updates. And you see here all the packages which have been synchronized and assigned. And you see here we just sign up the upstream URL. Everything looks fine. And by synchronizing, the package will be downloaded and the local mirror will be built. Of course, you don't want to synchronize regularly by hand, and you want to be your state as current as possible. That's why there are also so-called sync plans. So you can see here we created several sync plans to distribute the synchronizations over the night, because there are quite a few products running on orcharhino. So you see here we have a sync plan at midnight, 1 o'clock, 2 o'clock, 3 o'clock. You can set several sync plans as you like. So let's create just a demo sync plan. So you can set the interval to be hourly, daily, weekly, or a custom cron line. And then you just define the start time or the time on which this sync plan is supposed to run. The next step now would be when assigning content to create the so-called content views. So let's have a look at content views. In our case, we are building component content views and combining them in composite content views, but this is not necessary. You can work with component content views directly. So let's have a look on, let's open 2 tabs. Let's have a look on Ubuntu, on the composite Ubuntu, and Ubuntu itself. So we see here we have several versions. We have now our repositories defined. And whenever you need a new version, you can just publish a new version, and then there's something new available, but just on the actual state. Now here are our composite content view, which clusters several content views. So we have content view for Ubuntu, for the client, for SaltStack, and for Puppet. The advantage of this is that you can just update your different products independent of each other. It's of course a bit of more of work. So if you don't need the flexibility, you can just create one content view and assign them on one. And now we see here that we have different content view versions. So this is where the lifecycle jumps in. So we see if we have a server, which is a production server, testing server, it will be connected to a version 9.0 of our content view. If we have a development server, it will be connected to the most recent version, in this case, to the version 11. So, as I mentioned before, if I now say version 11 has been developed, it's ready for testing. We just go here, we click on promote, we choose testing, and click on promote version. So this is a task which is going to take a few minutes. And when it's done, the connection to the content will have been changed. Once this is done, testing servers will no longer be connected to version 9.0, but to version 11. So let's have a look on our server which we built before. So this was the webinar Ubuntu, it was this one. So you see, everything looks fine. It's basically like the server which we started patching before. Just to speed up a bit to wait as this server is done. So we see here now our reports. We see here now Puppet has been running and Ansible run as well. So it's normal configuration. Puppet runs every half hour, as I said. And as we defined, after 6 minutes by default, this number can be changed. All Ansible roles are run automatically on the server. So basically, if you want to deploy a server and you want to configure it with Ansible, you can assign roles, and then this will be automatically applied. And your server will be perfectly configured once everything is run. So we can see here now the different things further. So let's have a look on the facts. So here we have a summary of all the facts of a server which has been collected. So we see here facts collected by Puppet and by Ansible, but many, many more. We can go through a matrix. So we see we have here the report status. We see here the templates which have been applied. So basically this here explains and shows you what commands have been executed to install the virtual machine. Here we have the properties of the VM itself. We have again the network information and what I mentioned before, the snapshot plugin. So in case you want to make a snapshot, you just click here on snapshot. You give it a name. Descriptor is optional. If you want to include the RAM, you just check the RAM. If not, you leave it open and you click on submit. So you see the snapshot has been created. I can now rename the snapshot if I like to. So let's call it test2. If I click on this, the snapshot will be rolled back. And if I no longer need the snapshot, I just click on the garbage bin and can delete it. So Basically, you see, it's quite simple to deploy a machine. We can now just have a look on how to monitor everything. So basically, we can here have a look on the tasks which are running on orcharhino. We can have a look on the jobs which have been triggered. In case you want to have regularly status reports, you can just use one of these report templates. You can write your own report templates and just trigger them with cron job. And then, for example, every morning have your status report about your virtual machines. Here in the content, as I said, we can assign the repositories, the products, and content views. Here you can see how to assign, for example, this SUSE repository. So you go to the SSC plugin, you just enter your credentials, you synchronize it once, and once you've done that, you can click on Select Products, and then it will list all the subscriptions which are available for you for SUSE. So this is taking a bit. While it is working, okay, it's done already. You see now here all the different subscriptions. If you want to add an additional one, so which one looks nice? Doesn't matter. So let's just take this SUSE link server for SAP applications. You check this one, you submit, and now the products are being created. A similar principle, but different from usage, would be Red Hat. So you can go here to Red Hat repositories. The first step would be here in subscriptions. You see here Manage Manifest. You create a Red Hat manifest on your Red Hat website. Then you click here, and you can just choose File and upload your manifest. And once this has been done, you can go here to Red Hat repositories. And here on the right side, you will see the repositories which have been enabled for you. And on the left side, you can just choose additional ones. And then all of these repositories will be created automatically as well. So a different way to assign errata and do patch management would be to go to Content and Errata. So basically, if you want to patch several servers with a certain CVE, we can just list all the different errata. We choose the applicable installable, so it works out of the box. So let's take the BusyBox vulnerability. We can check this one. We can click on Apply Errata. So let's filter here a bit. So basically, you see here we have 4 different servers which are affected by this erratum. We have a 5th one here where we can see it's not currently installable in the host lifecycle environment. So basically, it's a test server. So this means that the fix for this erratum is only in development or in library. But nevertheless, we can create a so-called incremental update and just pull the packages which are required into the lifecycle and create a new one. So we can do that. So we just check all of the servers. We click here on Next. We see this is something for Ubuntu 18.04. We click here on Apply Errata to content host immediately after publishing. And once this has been done, it will just be applied. So we click here on Applying. And now an incremental update will be triggered. So this is with Ubuntu 18. So let's have a look if we already can see that or if it's still in the queue. Let's close it. Okay, here you already have it open. Let's close a few tabs. Has to be, okay, it's the wrong one. It's Ubuntu 20. We were looking for Ubuntu 18. So let's filter. So we see here our composite Ubuntu 18. And we see here this minor version is being triggered. So version 13.1 based on version 13, but adding required packages and errata to fix this issue. So if it's going to run for a while now, we'll just let it run. So what else can I show you? Let's have a look. So as I showed you before, we had our errata and patch management, but basically you might be willing to update certain packages outside of any CV issues or errata issues. So we can go back to content here. We can click on deb packages. So if we click here on installed, we get a list of all the packages which are already installed on the server in the current state. So we can check here and remove them, for example. Or if we want to do further action, we go here to apt actions. We can just type in a package name. We can install, update, or remove a package. In addition, if we look here on applicable, you will obtain a list of all the package versions which are available, which are newer when the ones have been installed. For example, so we see we have newer versions of account service, of Elsa UCM conf, of apt utils, and so on. So I can just pick one package, for example, and update that, or I can just update all the packages, for example. So let's upgrade the selected one. And now this is going to trigger the apt action again. So let's go back to our host page. So let's go back to Ubuntu 20. So we have seen many different features. So you can see here, you can define your installation media and your operating systems, which have been defined. So you see all the different media for deployments. We see the operating system we support. You see again the list we saw before the servers, Alma, CentOS, and much more. Here in configure, we have our host groups. Let's have a look on our host groups as well. You see here that all the different definitions we had were defined the parameters for all the different operating systems. We have certain global parameters which can be assigned to all hosts. Here we can define our Puppet environments and the different classes which has been pulled into. So let's have a look at the Puppet classes. Here we have our Ansible roles, and we have here our salt states. In addition, we can predefine all the different parameters. So basically we see here all the Puppet classes. We see here there are many parameters. We can just go into the class and edit the parameters. Here we have different Ansible roles which can be assigned. If we go here to Ansible variables, we can override the default values for the different roles. And the same applies to SaltStack. So basically also here you see, here we define where our hosts are being deployed. Here we have our t-shirt sizes, complete profile, so we can define several standards. For example, if you need a small server, a medium server, or a large server, and can just assign that. And when deploying, even fine-tune certain parameters which you would desire to be slightly different. And also you can assign certain user roles. For example, if you have a certain user group which is only allowed to view certain stuff, only edit certain hosts, you can define certain roles here and only permit certain things to be done. So basically, you have seen most of the available features in orcharhino. Now we can do our last step. So as I said, it maps the whole lifecycle of the server. So we see it has been built, has been patched, has been upgraded. And once you no longer need your server, you can just delete it with one click. So let's wait. And we see the server is gone. So this is the other server we had. So everything went fine. So now I arrived basically at the end of our live demo. So if you have any questions, feel free to ask. I will wait, I think something more, it was like 1 or 2 minutes in case that someone still has further questions. So apparently there are no further questions. So thank you for your participation and have a nice day. Bye.